Okay, let's unpack this. We are diving into what I think is, well, probably the biggest strategic realignment in enterprise AI this year. Microsoft's pretty radical move, consolidating everything into the new Microsoft Agent Framework MAF.
That's right. And the mission today really is for you, maybe you're a learner, maybe an architect, to quickly grasp the why this unification, and just as importantly, the how MAF is actually engineered to handle the really complex, non-deterministic automation challenges.
Right, because the interesting thing you mentioned is moving past RAG, retrieval augmented generation.
Exactly. RAG is, well, it's become baseline, hasn't it? Your smart chatbot. Great for answering questions based on existing knowledge.
But enterprise automation, it needs more than just a smart answer, right? It actually needs to do things.
Precisely. Action. MAF is focused squarely on the hard stuff. Reasoning, taking action, planning, and orchestrating those really tricky multi-step processes to get, actual business outcomes.
So we're talking systems that need that LLM reasoning power to make smart choices on the fly.
Yes, exactly. Filling that gap where, frankly, traditional RPA, robotic process automation, just hits a wall because it's too rigid. And this whole unified approach, it's delivered as an open source SDK. Good news for developers supporting both .NET and Python.
Okay, that brings us straight to, I think, maybe the most controversial bit of this whole announcement. MAF isn't just appearing out of nowhere. It's the direct successor, the replacement for two massive existing projects, Semantic Kernel, SK, and Autogen. And that's caused some fragmentation previously.
Oh, absolutely. And here's where it gets really interesting. Like you said, they've effectively merged them. And the big news, the potentially disruptive news for some, is that both SK and Autogen are officially transitioning to maintenance mode.
Maintenance mode. So bug fixes only, no new features.
That's the signal. Bug fixes only. The entire developer community, all future effort, is being directed towards MAF. It's the single path forward.
Okay, so let's break down that merger. SK was known for being, what, more enterprise-ready, stable?
Yeah, exactly. SK offered that established production-grade foundation, really strong on memory, stability, things crucial for enterprise deployment.
And Autogen was more the research frontier, more dynamic.
Research, darling, is a good way to put it. Very dynamic, fantastic for exploring complex multi-agent collaboration. Real research strength there.
So on paper, MAF sounds like the dream ticket, right? Autogen's cutting-edge agent collaboration bolted onto SK's rock-solid production base.
That's the goal. Best of both worlds.
But let me push back a little here. If I'm a chief architect and my team just spent the last year, maybe 18 months, deeply integrating semantic kernel into our core systems, isn't Microsoft just handing us a massive new chunk of technical debt? Deprecating SK and Autogen at the same time, forcing this migration? That sounds painful.
That is a fair question, a really critical one for people in that position. But the argument, the rationale from Microsoft's side is about mitigating future technical debt, not just shifting the current burden. Well, the reality was the two projects, SK and Autogen, they were diverging significantly. Maintaining both, ensuring compatibility, dealing with different approaches, it was becoming a maintenance nightmare. And for enterprises committing long-term, that divergence created a huge fragmentation risk. Which one do you bet on?
Okay, so unifying into MAF, it provides that single, clear, long-term supported path, guaranteed quality baseline.
Precisely. It minimizes that long-term risk. It's a tough transition for some, no doubt, but the aim is a more stable future.
Okay, fair enough. So what are the immediate, tangible production benefits that make this migration worth the potential pain? What does MAF give me now?
You get several enterprise-grade necessities baked in right out of the box. Things that, honestly, were a bit kludgy or inconsistent between SK and Autogen individually. Like robust, thread-based state management. Absolutely essential when you have agents involved in long-running conversations or processes. Built-in, comprehensive telemetry for monitoring, crucial for production. Real-type safety, which developers appreciate. And much more extensive support for different models and embeddings.
So it's the stability and the completeness, not just shiny new features.
It's the production readiness,
Okay.
The stability. That's the core justification for demanding this shift if you're building serious production systems.
Yeah.
MAF is positioned as the path forward, period.
All right, so they've hopefully sorted out the internal project chaos. Let's drill into the MAF agent itself, the building block. What are the core structural decisions they've baked in? If MAF is the foundation, what are the essential components? You said 3.
Yes, 3 core components.
Wow.
And the structure enforces a really critical design philosophy, the separation of concerns. It's fundamental to how MAF works.
Okay, component 1.
Reasoning. That's the brain, like you said earlier. The decision maker. Usually, yes, it's an LLM, but the architecture is flexible. You could, in theory, plug in other AI planners if
What's that
needed.
component too?
Context. Basically, everything external the agent needs to inform its reasoning. Your knowledge bases, vector stores, the conversation history up to that point, external data feeds, all that.
And number 3 must be tools.
Tools, exactly. These are the callable capabilities, the APIs it can hit, the database queries it can run, the functions that let the agent actually act on the world or gather more specific context.
And you mentioned separation of concerns. Why is that structure so important? Is it mainly for debugging?
Debugging is a huge part of it, absolutely. It's almost non-negotiable for reliable systems. The rule is strict. Tools execute tasks or gather context. That's it. They are prohibited from making the final decision about what to do next.
So if something goes wrong.
You know where to look. If the agent makes a bad choice, say it decides to call the wrong API for the situation, you know it's a failure in the reasoning component. Probably a prompt engineering issue, or maybe the model needs fine-tuning.
Okay.
But if it correctly decides to call the update customer record API, and then that API call fails with a 500 error, well, that's clearly an execution failure, a tool bug, nothing wrong with the agent's reasoning.
Got it. You can isolate the problem instantly. Reasoning issue versus tool issue. That clarity, especially in a live production system. Yeah, that seems incredibly valuable.
It is. It saves enormous amounts of time during troubleshooting.
Okay, that makes sense. Now let's talk flexibility. Microsoft is driving this, obviously. How do they prevent enterprises from feeling locked into only using Azure OpenAI? Especially with, token costs being so volatile. How do you keep control?
Yeah, that's the million-dollar question, isn't it? The architectural answer, the sort of insurance policy they provide, is the iChat client abstraction.
iChat client. Okay, what does that do?
It's an interface provided via the Microsoft.extensions.ai library, and it standardizes how any MAF agent interacts with any compatible chat model. This is really key.
So you code your agent logic against this standard interface.
Right.
And then behind that interface, you can plug in Azure OpenAI, sure.
Yeah.
But you could also plug in, say, a model running locally via a Llama, or maybe one of the specialized models from Hugging Face or GitHub.
Precisely.
Mm-hmm.
As long as there's a provider that implements the iChat client interface for that model endpoint, the agent doesn't care. It just talks through the standard interface.
So if, hypothetically, Azure OpenAI token costs suddenly triple next quarter?
Or if a particular model endpoint starts suffering performance issues or maybe becomes unavailable, you can swap out the underlying provider, maybe switch to a different model, maybe even a different vendor entirely.
With minimal or maybe even zero changes to your core agent code.
That's the goal, minimal code change. It's designed explicitly to prevent vendor lock-in at the model level and give enterprises a way to mitigate risks around cost volatility, performance fluctuations, and model availability. It's a crucial, strategic decision for stability in what's still a pretty chaotic AI market.
Okay, that iChat client abstraction sounds massive, really important for architects. Let's shift gears slightly. We've talked about the single agent, but real enterprise tasks are often complex, right? They involve multiple steps, maybe coordinating several agents or calling dozens of different APIs. A single LLM trying to manage all that state, all that context in its prompt, that seems like it would break down pretty quickly.
It absolutely does. The context window limitation is real. And that's exactly where workflows come in. They act as the orchestration layer on top of individual agents and tools.
So workflows are like the scaffolding for complex tasks. Why is this explicit layer needed?
Because you need to impose some deterministic structure, some control over these potentially non-deterministic processes, especially as complexity grows. Think of it like this. When an LLM has to juggle, say, more than 20 different tools or potential actions in its prompt, its ability to reliably choose the right one degrades rapidly. It gets overwhelmed.
Right, too many choices.
Exactly. Workflows let you define the execution path. They structure the overall objective into manageable steps, and they're highly composable. You can sequence tools, individual agents, or even embed other workflows within a larger workflow.
Composability. Okay. And what about long-running processes? Things that might take hours. What happens if the server running the workflow crashes halfway through? Do I lose everything?
That's a critical enterprise concern, and the answer is durability, provided through server-side checkpointing.
Checkpointing, like saving your game.
That's a perfect analogy. The workflow automatically saves its state at predefined points, or potentially after specific steps. If there's an interruption, a server crash, a network blip, whatever the workflow can be fully recovered and resumed right from the last save checkpoint.
So that 6-hour month-end reconciliation process doesn't have to start from scratch if there's a hiccup at hour 5.
Exactly. It picks up where it left off.
Hmm.
That kind of durability is absolutely non-negotiable for any serious enterprise automation. You can't risk losing hours of work.
Makes sense. Now, you mentioned orchestration patterns. How do we actually use this workflow scaffolding? I think you identified 4 main patterns.
That's right. 4 key patterns that cover most common orchestration needs. The first 2 are about basic structure.
Okay, pattern 1.
Sequential. This is the most straightforward, just a linear pipeline. Step A happens, then step B, then step C. Think, extract data from a document, then cleanse that data, then generate a final report. Simple linear flow.
Got it. Pattern 2.
Concurrent. This is about parallel processing. You might broadcast the same task to 2 different agents simultaneously. Maybe one uses model A, the other uses model B to get diverse perspectives. Or maybe it's for redundant validation, run the same check twice in parallel. Then you can merge or compare the results.
Okay, sequential and concurrent. Simple enough. Then things get more dynamic. What's the handoff pattern?
Handoff is where control passes dynamically between different agents or processes based on specific rules or maybe capability limits.
Give me an example.
Classic AZ. A general customer service chatbot handles initial intake. But when it encounters a really complex technical question about, say, network configuration, it hands off the conversation to a specialized network expert agent. The control moves based on the context.
Ah, okay. And does this relate to bringing humans into the process?
Absolutely crucial point. The handoff pattern is the primary mechanism for implementing human-in-the-loop, or HITL, scenarios.
How does that work?
An agent might reach a point in a process where human approval is mandatory, maybe a financial transaction over a certain limit, or a compliance check. The agent uses the handoff pattern to pause the automated workflow and route the context and decision point to a human manager via some interface. Could be Teams, email, a custom app.
And the workflow just waits.
It waits. The human reviews, makes the decision, approves or rejects. Then they hand control back to the agent or workflow, which resumes based on the human input. That HITL capability is vital for regulated industries or critical processes.
Vitals is right. Okay, so that handoff. What's the final, most advanced pattern? The one you said came more from the Autogen research side. Magentic.
Magentic, yes. Think of this as the multi-agent team coordination pattern. It's designed for the most complex, often open-ended problems where the exact solution path might not even be clear at the start.
So not just a simple handoff, but ongoing coordination.
Exactly. You typically have a dedicated manager agent whose job isn't to do the work itself, but to coordinate a team of specialized agents. Based on the task progress and the evolving context, the manager dynamically selects which specialist agent should take the next step. It's constantly assessing and directing the flow of work across the team.
What kind of problem needs that?
Think complex, real-time analysis, like analyzing a major supply chain disruption. The manager might need input from a finance agent, then a logistics agent, then maybe loop in a manufacturing agent, dynamically deciding the sequence based on the unfolding situation.
Okay, so that's for the really hairy multi-domain problem.
Precisely. It's powerful, but also complex to set up and manage. The advice is generally, don't jump straight to Magentic unless you have a clear need for that level of dynamic, open-ended, multi-agent problem solving. Start simpler if you can.
Good advice. Don't over-engineer. Okay, speaking of complex environments and regulated industries, fancy orchestration is great, but it needs to be production-ready, secure, governed. What makes MAF truly enterprise-ready in those aspects? Is this just an Azure-centric thing? Do my MLOps teams need to learn a whole new deployment stack?
That's a great point, and actually one of the goals seems to be lowering the operational barrier, not raising it.
How so?
Because MAF is built on .NET, it leverages familiar .NET hosting patterns. We're talking standard things like dependency injection, middleware pipelines, stuff that .NET teams already understand well.
So I can host a MAF agent like I host my other ASP.NET Core web APIs?
Essentially, yes. Your MLOps teams likely don't need to learn entirely new infrastructure tooling just to deploy and manage an agent. That significantly lowers the operational expenditure, the OpEx, compared to introducing a completely alien stack.
Okay, that's a big practical win. Reduced friction for deployment. But what about the CSOs? The compliance officers? What's built in for them?
That's where the tight integration with the Azure AI Foundry governance services really comes into play. It provides critical, built-in, responsible AI capabilities. These are currently in public preview, but they address major risks,
Like what specifically?
Well, for starters, robust PII detection, automatically identifying and potentially masking personally identifiable information in conversations or data processing. That's absolutely mandatory for regulations like GDPR here in Europe or CCPA in California.
Okay, PII detection. What about security threats like prompt injection, people trying to trick the agent?
They're tackling that with prompt shields and spotlighting. These are designed to detect and mitigate various prompt injection attacks, adding a crucial layer of security. There's also task adherence monitoring, which helps ensure the agent stays focused on its assigned job and doesn't drift into unintended or harmful behaviors. Preventing that functional drift is key for reliability.
Right, and agents often need to interact with core backend systems, right? Update an ERP, queries a sensitive database. How do they authenticate securely? Surely not with hard-coded passwords in the agent config.
Oh, definitely not. That would be a disaster. MAF agents are designed to connect to tools, especially internal enterprise APIs, using standard open API specifications. And critically, they have built-in support for using managed identity for authentication when interacting with Azure resources or services that support Azure AD authentication.
Managed identity. So no credentials stored in the agent's code or configuration. It uses its own secure identity managed by Azure.
Exactly. It enables secure, role-based access control, RBAC, for the agent when it calls other services. You grant the agent's managed identity the specific permissions it needs and nothing more. It completely avoids the massive security risk of hard-coded secrets.
That's essential. Okay, we established earlier that iChat client helps avoid model vendor lock-in. What about framework lock-in? If my company already has pockets of development using, say, LangChain, can a new MAF agent talk to an existing LangChain agent, or are they siloed?
That's another area where Microsoft seems to be making a strategic bet on openness. MAF explicitly champions and supports open standards, including the emerging agent-agent HOA protocol.
A2A protocol, what does that enable?
It's designed to allow agents built on different frameworks to communicate and coordinate securely. So yes, an MAF agent should be able to interact, invoke actions, and exchange information with an agent built using LangChain or Google's Vertex AI or any other framework that adopts this common protocol.
Wow. Okay, so interoperability between different agent frameworks. That's actually huge for large organizations that inevitably end up with multiple technologies.
Yeah.
Avoids creating new silos.
It's definitely a game changer for heterogeneous environments. Fosters collaboration rather than competition between frameworks, at least at the communication level.
And one last piece for enterprise readiness. Cost management. LLMs aren't free. How do you track usage and costs, especially with potentially complex workflows involving multiple agents and model calls?
Through comprehensive built-in monitoring via OpenTelemetry, this is becoming the industry standard for observability.
So it captures the usual stuff, errors, conversation flows.
Yes, error tracking, tracing the flow of conversations and actions through workflows and agents. But the critical piece for the finance folks, as you mentioned, is the detailed tracking of model usage. This includes granular data on token consumption prompts and completions, and crucially, associating that usage with costs. Given the consumption-based pricing of most powerful LLMs, having accurate auditing and cost optimization capabilities baked in is absolutely mandatory for scaling these solutions across an enterprise.
You can't manage what you can't measure, especially when it comes to potentially spiraling LLM costs.
Exactly right. OpenTelemetry integration provides that necessary visibility.
Okay, we've covered a lot of ground. The why, the how, the architecture, the orchestration, the enterprise readiness. Let's try to summarize the positioning here. MAF seems like a very deliberate, unified platform play by Microsoft. It feels like a direct challenge to the more Python-centric frameworks, maybe offering more guaranteed stability and, crucially, that built-in governance layer via Azure AI Foundry.
I think that's a very accurate summary. It's positioning itself as the secure, manageable, enterprise-grade option, particularly strong within the .NET ecosystem, but also supporting Python. And just to put dates on it, MAF was announced as a public preview back on October 1st, 2025. The current official target for general availability Agent Framework 1.0, stable APIs, full support SLAs is the end of Q1 2026.
End of Q1 2026 for GA 1.0. Okay. So boiling it all down, what does this mean for you, the listener, perhaps the chief architect or lead developer, planning your AI strategy for the next 12 months? What are the key takeaways or recommendations?
I'd offer two main recommendations. First, adopt a measured approach. Don't try to boil the ocean immediately. Start with building robust single agents using standard tool calling. Honestly, that pattern, a single reasoning agent augmented with well-defined tools, is the immediate sweet spot. It probably covers 80% or more of valuable enterprise automation use cases right now.
So master the basics first.
Exactly. Only deploy the more complex magentic multi-agent systems when you have a clear, undeniable need for that dynamic cross-domain collaboration. Don't over-engineer your initial projects just because the capability exists.
Makes sense. Keep it simple where possible. What's the second recommendation? Sounds like an architectural mandate.
Yes, mandate abstraction at the model layer. Specifically, enforce the use of the iChat client interface across all your development teams building MAF agents. Even if today you are 100% committed to Azure OpenAI, build against that interface.
Why is that so critical?
Because it preserves your architectural flexibility. It's your escape hatch. It allows your organization to mitigate future model vendor risks, react to cost changes, switch providers if needed for performance or availability, all without needing to rip out and rewrite your core agent logic. It future-proofs your investment.
Okay, so 1, start with solid single agents. 2, always use iChat client for model interaction. That's clear, actionable advice. Thank you. Before we wrap up, as always, we like to leave our listeners with something a bit more provocative to think about. What's the final thought we should mull over regarding this whole MAF landscape?
Well, looking just beyond the Agent Framework 1.0 GA, the MAF roadmap has another major milestone slated for Q2 2026. That's the planned general availability of the process framework.
Process framework, what's that?
Think of it as extending these agent-based reasoning capabilities into the world of more deterministic, traditional business process orchestration. But here's the kicker. The roadmap explicitly mentions incorporating visual design surfaces and low-code authoring tools for this process framework.
Low code, for building these kinds of AI-driven automations.
Exactly. So the question I'd leave you mulling over is this. What happens when structured low-code authoring tools arrive for building and deploying these powerful reasoning-based automation systems? What does that mean for the speed of deployment across the entire enterprise? Could it potentially put the power to create sophisticated AI agents directly into the hands of line-of-business developers or even power users, not just specialized AI engineers? That democratization could radically accelerate adoption.
A low-code future for dynamic reasoning agents. That definitely changes the game regarding who can build these systems and how quickly they can spread. Something to watch closely. Thank you for cutting through the noise in the marketing to give us the real technical breakdown of this massive shift with MAF. That was incredibly insightful.
My pleasure. It's certainly a space that's evolving rapidly.
And thank you for joining us for this deep dive. We'll catch you next time.